Dangal greetings. This is our main method or the introductory part of our project. I will explain to you the introductory part of our main class. So please bear with me. So in this program, the main class serves as a starting point of our program. So where everything begins when you run the toy collection manager. It starts by setting up a few important tools such as array list, name toy collection. To store this, the purpose of it is to store all the toys object, and there is a scanner called input scanner. So this is to read the user input, and also string menu choice, which is a variable, is also declared as a string to hold the user selected on the menu option. So this program or the program then greets the user with the welcome message. So it prints welcome to the toy collection manager. So next, it prints another message. We're here to help you manage your cherished toy collection with ease. So it has space below the first line. So introducing the toy collection manager as a tool to help organize their toy collection. After this setup, a loop will be done. So it is a do while loop. So it's used to repeatedly display a menu with options like adding, removing, displaying, searching, and filtering the toys, and also an exit button until the user chooses to exit. So inside the loop, the user choice is captured using the get menu choice method. So I will explain to you the two methods that we use. So depending on what the user is, user select, whether it's different methods like add new toy, remove toy by ID, or display all toys. These are called to handle those tasks. So the loop only ends when the user picks X or exit, after which is the scanner is closed, and then the program thanks the user after using the system. So now I will explain to you what is the get menu choice method. So in this method, it is a helper function that ensures the user input a valid menu option. So it repeatedly asks the user to enter a choice. It checks if it is exactly one character and compares it with the list of the valid options like the A, B, C, D, A, B, C, etc. And if the input is valid, it returns the choice. So if not, so it prompts the user to again until a correct input was given. So this is basically the body of our get menu choice method. So next, let's get into the get positive double method. So the get positive double method is basically another helper function that ensures the user's input is a positive number or the int symbol. So it keeps asking the user to enter a numeric value, and if the value is greater than 0, it returns it. So if you know, positive numbers also count when the user input greater than 0. So if the input is invalid, like a letter or a negative number, it shows an error message and asks the user to try again. So that is the main or the introductory part of our main, and the summarization of the get menu choice and the get positive double.
Hi everyone, I'm Angel Taac Taac, and today I'm going to explain three key methods from our Toy Collection Manager program: Get Boolean option, Get Toy Condition, and Get Interactive feature. I'll walk through each method, explain its purpose, and point out the important lines of code so you can see exactly how they work. Let's start with the Get Boolean option method. This method's purpose is to ask the user a simple yes or no question and return a corresponding Boolean value. Notice here that it takes two parameters, a scanner object to read user input and a prompt string that displays the question. Here, the array valid choices is set to A and B. This represents yes and no. The method then prints the prompt and lists the options A for yes and B for no to clearly guide the user. Here. Next, it calls the get menu choice method to ensure the user enters a valid choice. Here. Finally, based on the user's response, if they choose capital A or small a, the method returns true, otherwise, it returns false. This structured approach ensures that we always have a valid yes or no answer to work with in our program. Next, we have the get toy condition method. This method is designed to capture the condition of a toy, offering three choices: new, use, or refurbish. First, the method prints a message asking the user to select the toy's condition and then displays the three options. It again uses the get menu choice method to ensure the input is valid. Depending on the user's input, the method returns the corresponding string value new, use, or refurbish. This method makes it easy for users to specify the toy's condition in a consistent and controlled manner. Finally, let's talk about the get interactive feature method. This method adds flexibility by allowing the user to select an interactive feature for the toy. Initially, the method presents four options: A for voice recognition, B for touch sensitivity, C for none, and D for other. And please specify. Here. After displaying the options, it calls get menu choice to capture a valid selection. If the user selects options A, B, or C, the method directly returns the corresponding string value. However, if the user selects option D, the method then prompts them to enter a custom interactive feature. If no input is provided, it defaults to none. This approach not only gives users predefined choices but also allows for customization, ensuring that any interactive feature can be accommodated. Yeah, that's it for me.
Okay, let's start with the get toy dimension method. The get toy dimension method asks the user to enter a toy's length, width, and height in centimeters. It is used a get positive double method to ensure the inputs are valid positive numbers. Finally, it returns the dimensions as a formatted string. Let's talk about add new toy method. The add new toy method collects details from the user to create and add a new toy object to the toy collection. It ensures valid inputs for the toy's name, condition, manufacturer, dimension, weight, battery, operation, sound features, and interactivity. After gathering the data, it creates a toy instant and adds it into the list, confirming the successful addition. Lastly, let's talk about the remove toy by ID method. The remove toy by ID method allows the user to remove a toy from the toy collection by entering its ID. It ensures valid numeric input and searches for the toy in the list. If found, the toy is removed and a confirmation message is displayed. If not found, it notifies the users.
In this line of code, here, display all toys stored in the toy collection list. If the collection is empty, it informs the user. Otherwise, it iterates through the list and calls display details for each toy. This line of code searches for a toy in the collection by name. Next, asks the users for a name input, then iterates through toy collection, and check if the name matches, ignoring the case. And if a match is found, It displays the toy's details. Otherwise, it informs the user that no matches was found. Here, in this code, filter toys by condition. Filter the toys based on their condition: new, used, or refurbished. Prompts the user to select a condition. Iterates through the collection and displays only the toys that match the condition. If no toys match the selected condition, it informs the user.
So let's get into the toy class of our project, and I will explain the introductory part of the toy class, which consists from line 1 to line 15. So this line 1 to line 15 is where it contains the class fields. So in this toy class, it is a blueprint for creating individual toy objects. So each represents a toy in the collection. At the top, we have the private static int toy ID counter. So this toy ID counter, it keeps the track of the next toy ID. So it starts from number 1. So it is equal to 1. So there are several fields or variables, or what we call variables, and these variables describe the details of a toy that the user will be input. So the toy ID, it's automatically assigned based on the toy ID counter. So below it is a private string toy name. So the private string toy name is basically the name of the toy that has been given. And next or below it is a private string toy condition. The toy condition, from the word itself, it specifies the condition of the toy, whether it's new or used or refurbished. So those three are the options. Then next is the private string toy manufacturer. And also from the word itself, this is specifies the company that made the toy. So next is the private string toy dimensions. From the word itself also, this specifies the dimensions of the toy. Its size, its length, its width, and its height. So additionally, there is a private double toy weight. So in this specify the weight of the toy, but specify only in grams and grams only. So it is strictly on grams. So below it is a private boolean is battery operated. So when we say boolean, so it is a true or false. So it depends on whether it's need batteries or the toy needed battery. So that is the purpose of the private boolean is battery operated. And below it is a private boolean also has sound features. So in this field, this is also a true or false, but depends on whether the toy makes sound. So from the word itself, has sound features. So finally, below it is a private string interactive features. Also from the word itself, interactive features, so it is specifying if the toy has like voice recognition or touch sensitivity. So that is basically the introductory part of the toy class. So this part is very crucial to run the code. So these fields work together to fully describe the characteristic of each toys that will be inputted by the users to run the program.
I'd like to walk you through the constructor of the toy class found in toy.java. This part of our program is critical because it defines how each toy object is created and initialized with its details. First, take a look at the constructor signature. This constructor takes several parameters, each representing a different attribute of a toy. It's designed to ensure that every toy we create has all its details properly set from the moment it's instantiated. Here, this.toy ID equals toy ID counter plus plus. Here, you'll notice that before we even assign the values from our parameters, we're we are automatically assigning a unique toy ID. The static variable toy ID counter is used to generate these IDs. Each time a new toy is created, the current value of toy ID counter is assigned to the toy ID field and then the counter is incremented. This mechanism guarantees that every toy has a distinct ID here. Each line here assigns the parameter value to the corresponding field in the toy object. By using this keyword, we are clearly differentiating between the instance variables and the parameters with the same name. This ensures that the toy's properties such as its name, condition, manufacturer, dimensions, and even features like battery operation and sound capabilities are stored as part of the object. This constructor is responsible for assigning a unique ID to every toy using the static counter, initializing all the properties of the toy with the values provided at the time of object creation, ensuring that every toy object is fully set up with all necessary details as soon as it is created. This design helps maintain consistency and ensures that all toy objects in our collection are initialized correctly. That covers the constructor in our toy class.
Okay, let's talk about Thus provides getter and setter methods for managing toy attribute. Get next toy ID returns the next available toy ID. Get toy ID retrieves the toy's unique ID. Getters return details like name, condition, manufacturer, dimension, weight, battery operation, sound features, and interactive features. Setters allows updating these attributes. These methods ensure controlled access and modification of the toy property.
So, in this code, the display details method prints a formatted summary of a toy's details using this box of drawing characters for structure. It uses printf for aligned output, ensuring labels and values are neatly spaced. It prints a decorative header, toy details, and displays the toy attribute, ID, name, condition, manufacturer, dimension, and toy weight. Checks and prints booleans for properties, battery operated, if yes, and no, if it's not battery operated. Yes, that's it. Also, it checks and prints booleans properties, battery operated, and sound feature. And it displays interactive features, voice recognition, or some other. Lastly, it prints a closing border for a clean output.